Hi, and welcome to this video explanation of elimination in section 7.3. Here we're going to take a look at a slightly tougher question, question number 20. So we see 11y minus 3x equals 18, and negative 3x is equal to negative 16y plus 33. Now what makes this question a little bit more challenging than the others? The answer is that currently our variables are not lined up in the same positions as each other, so it's a little bit harder to combine them together and try to eliminate one of the variables in order to solve our system of equations. So my recommendation is to follow this general formula of an x term, a y term equals a number. So let's see if we can rearrange these equations so it looks like an x term first and then a y term equals a number. So for the first equation, we have 11y minus 3x equals 18. So in order to put your x term first, we simply have to switch the order that these two terms, the x and the y term, are written. So we have negative 3x plus 11y equals 18 for that. Now, for our second equation, we have a little bit more of a challenge, because it's not just about switching around the order that we're writing it, but we actually have to do a little math here and a little manipulation of our equation to bring y to the other side. Currently, we have an x term by itself, but we want to bring y over, which means we need to add 16y to both sides. So when we do that in this equation, we're going to be left with negative 3x plus 16y. So remember, we added it when we moved it to the other side, is equal to 33. Now this looks a little bit more like what we're used to seeing for elimination, but here we still have a negative 3 and a negative 3, which don't cancel out each other. Instead, they would add together to give us a negative 6. So to cancel one of them out, we need to multiply one of the equations by a negative value. So if we multiply this top equation by negative 1, then once we distribute that negative and change the sign of each term, we'll have x values that will cancel out. And let's take a look at how that works. So negative 1 times negative 3 would give us a positive 3x, and then minus 11y equals negative 18. And our second equation remains exactly the same. So when we distribute the negative 1, if you notice, the sign of each term changes. This becomes positive 3, negative 11, and negative 18. Our second equation is written the exact same way. We don't have to change a thing. And now we finally are left with two equations that are set up for elimination. And we simply add the two equations together. Positive 3 and a negative 3 cancel. Negative 11 plus 16 would give us 5y. Negative 18 and plus 33 would give us 15. Divide both sides by 5. And we're left with y equals 3. And we're not quite done. We still have to plug that value back into one of the equations to solve for x. So if we want, let's try this first equation here. We have 11 times 3. So I'm just plugging in a 3 in place of y. We have 11 times 3 minus 3x equals 18. 33 minus 3x equals 18. Subtract 33 from both sides. Negative 3x will equal negative 15. And when we divide by negative 3, I apologize, the board work is a little cramped here, we're going to be left with x equals 5. So sorry that we ran out of space there, but hopefully we can follow the work. We get x equals positive 5 and y equals 3 as our solution to question 20 in section 7.3. And really the key to notice there is that when you have an equation that's not written with an x term, a y term equals a number, we want to rearrange the equation so that it's in that form to allow us to set it up the way that we're used to seeing our elimination questions written. If you have more questions, feel free to leave a comment, and I'll be happy to post an answer there or post a video response. Thanks for watching.